All right, guys, so I'm going to do the first one of these this week. Usually, as you guys know, I do FRQ notes and then practice, but these are also similar. I think they're pretty basic, straightforward, like we did in class. I'll just do one for you, and then I'll let you guys handle the rest of them. So this is the 2007 one. Let's go ahead and begin here with it. All right, so we have a table. Says we're looking at the volume of a spherical hot air balloon that's expanding as it's heated. They've given us the radius of the balloon is in feet, but notice that what they're giving me here is r prime, which means this is telling me how fast the radius is changing. So at t equals 0 minutes, the rate of change of the radius is 5.7 feet per minute. And then at 2 minutes, the radius is increasing at a rate of 4 feet per minute. At 5 minutes, the radius is increasing at a rate of 2 feet per minute, etc. So it looks like it's increasing, but at a slower and slower rate over time. So there's that. Let's see. We're going from 0 to 12, so that's a good thing to notice there. Tells us stuff about concavity. We're not going to really care about this for this part of the problem. This is part C. The concavity thing would come in handy for the other parts of the FRQ here, but we're not going to be using that at all. All right, same thing with the volume formula. We're not going to be using that. So let's begin here. So it tells us here to use a right-Riemann sum. So right-Riemann sum with 5 subintervals in the data indicated by the data in the table to approximate this. Now, we're going from 0 to 12. That's important to pay attention to. They don't always want you to do the whole table. They may only want you to do part of it. But in this case, they do want us to do the whole table. We're going from 0 to 12. So we are going to do the whole table. So we're going to do that. So that's one thing that we're going to do is we're going to use a right-Riemann sum with 5 subintervals to estimate this. That's one thing. But they also want us to do units, and they also want us to explain the meaning. So there's 3 things that they want us to do here. My guess is this question could be worth anywhere from 3 points to 4 points of an FRQ. They would possibly make this first one here with your estimation. They might make that worth 2 points, doing the setup correctly and then getting the final answer. Or they might be stingy and only give you 1 point for it. The correct units might be worth a point, and the explanation might be worth a point. Sometimes, once again, if they're being stingy, what they'll do is they'll just kind of combine both of these together into 1 point. So an explanation with the units might be worth 1 point. So this question, you're looking at anywhere from maybe 2 points at the absolute least, like if they only give you 1 point here and 1 point for this, or up to maybe possibly 4. They might give you 2 points here and 1 for each of these. So it could be anywhere in between those values. But without any further ado, let's go ahead and get started here. So we're doing a right-Riemann sum. My base of the rectangles that are formed by this right-Riemann sum would be here, 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 and here. So those are my base lengths. And since we're doing a right-Riemann sum, we'll be using all of these as our heights, and we won't be using the last one. So it's going to be base times height, base times height, base times height, base times height, base times height. Okay, so here we go. We'll have the integral from 0 to 12 of r prime, I put f, r prime of t is going to be equal to 2 times 4 is 8 plus 6 plus 2.4 plus another 2.4 plus 0.5. And this is an FRQ, so we really don't need to add all that together. We can really just leave it like that. If you wanted to take the time to add it together, you could, but it's not necessary. Okay, so I think I'll go ahead and stop there because I don't want to go get my calculator, but you could add them up if you want to. Now, it says using the correct units. All right, well, right now you guys can see that this is feet per minute. When you integrate r prime of t, you end up getting regular r of t. And it tells us here in the problem that the radius, r of t, is in feet. So this final answer here, after you would add all these things up, is in feet. And basically what it does is it tells you how much the radius has changed from t equals 0 to t equals 12. We're going from 0 feet, I'm sorry, t equals 0 to t equals 12. It was changing this fast for that long, 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 and this fast for that long. Multiplying all those together, you get the total amount of feet it changed. So what this is that we could say that this represents the change in r on the time interval (0 to 12). All right, and that's pretty much it. So this represents how much the radius changed on the time interval from 0 to 12. And we should probably put in there in feet. Although I did put my answer there already for the units. There it is. So once again, when you guys are doing an interpretation, remember, you need your context. You need your input units. In other words, what your t or what the input variable is measured in. And then you also need your output units, which is in feet. Okay? So 3 things are required for an interpretation when you're explaining the meaning. And the correct units, well, since r prime is feet per minute, the integral of r prime is r, which they tell us is just feet, so it gets rid of the minutes. So we have our 3 things. We have our answer, which I didn't choose to add up. We have our units, and then we have our explanation. And like I said, the first part up here could be anywhere from 1 to 2 points, and the explanation could be worth 1 to 2 points, depending on how they want to score it. So, all right, so I'll leave the rest for you guys to do. Hopefully that was helpful, and we'll see you guys later.